Welcome to the case study on Zomato restaurant data analysis. So in this case study, we are going to analyze the Zomato dataset. It will give us the idea about factors which are affecting rating of each restaurant. This dataset is of Bangalore city and it has more than 12,000 restaurants. And the restaurants are serving so many different kind of dishes which are served all around the world, like Chinese cuisine, Japanese cuisine, Italian, Arabian, Indian, and so many other dishes. Bangalore being an IT capital of India, most of the people here are dependently mainly on restaurant food. As there is high demand of restaurants in Bangalore, it's very important to study the data and study the demographics of various locations. There are people who are vegetarian, there are people who are non-vegetarian. So we need to do an analysis of different kinds of cuisines and rating of the restaurant. Zomato is a company that offers restaurant search, discovery app and a website. It provides in-depth information about the restaurants. Zomato is used by consumers to discover, rate and review restaurants. If you are a foodie and if you are living in any metro city of India, you might be aware of Zomato and Swiggy. I think Zomato and Swiggy are the only options to order food now. Maybe in future we'll get a few more other options to order food from any restaurant. So it's different comparing to McDonald's and Pizza Hut, because in Pizza Hut app you will only order food from Pizza Hut, but from Zomato application you can order food from any restaurant of your city. And even you can order food online or book a table through Zomato. Zomato is used in both ways, ordering food online and for dine-in. Let's start the project now. So this is the dataset CSV file. So I'll share you these two things, like this CSV file and IPython notebook. I'll share the link to this folder and you can download it and you can upload it into your drive and you can start working on it. You can also work on Jupyter Notebook, but in my case I'm working on Google Colab. So this is our Zomato restaurant analysis case study notebook. So here we have information about all the columns which are in the dataset. So we have URL, it contains the URL of restaurant in the Zomato website, and we have address that contains the address of restaurant in Bangalore, and we have name that contains name of restaurant, and we have online order column, whether the online ordering is available in that restaurant or not. Then we have book a table column, so whether we can book a table to dine in or we need to only purchase online. And then we have rate, where users give the rating out of 5, and we have vote, by which we can know that how many people have rated it till now, and we have phone number of the restaurant, and we have location of the restaurant, and we have rest type, which is restaurant type, and we have dish liked, so dishes people like in the restaurant, like if there is some particular restaurant which is famous for Arabian dishes. So and then we have cuisines. Here we have food styles separated by comma, and then we have approx cost for 2 people, so it will be around 800,000. so the approx cost for 2 people to eat meals over there. And we have reviews list. So if you have given any review to that restaurant, like I like the food here, so that's a review in the form of text string. And then we have menu item, so total number of items in that restaurant. And then we have list in type, the type of meal, buffet or lunch, breakfast, dinner. And then we have listed in city, that contains information about neighborhood. So these are all the columns which are available in this dataset. So here in this case, at the end we are going to predict reviews. So if there is a bad restaurant and you gave it good review, I mean you recommended it to your users, then the experience of that user will be not that good, like, so the experience of user will be bad. So let's proceed further. So first we are importing all the important libraries. So here we are importing GeoPandas, we are importing Plotly, we are importing Folium. Folium is used to create maps, and GeoPandas is used to work on geospatial data. So after importing all these important libraries, we are also importing NLTK. We are importing stop words. So after importing all the important libraries, we can proceed further. Now let's mount the Google Drive. So we need to authorize our access. So I'll click on this link, and we need to give access to our Google Drive. So I'll select the email ID, and then we need to copy the authorization code. So once you click on your Google account, it will give you an option to allow. So once you allow all the permissions, here it's authorization code. So you have received the authorization code. After receiving that, you need to paste it here and you need to run this cell. Let's run this cell. Now let's visualize the data. Let's import the data now. When we click here, so it's giving an error. So let's check. So here no such directory. Okay, so I think I have changed the path. So I'll go to my drive. I'll go to projects folder, and then I'll go to Zomato restaurant data analysis, and I'll copy the path to this file, and I'll close this. I'll come here and I'll remove everything in between these quotes, and I'll paste the link, path to my dataset. So, and I will check top 5 rows of my data frame. So I'm writing df.head to visualize top 5 rows. So we are importing our data now. So the data set is very huge, so it will take some time. So this is the URL. So zomato.com Bangalore/Jalsa Banashankari, I think. So the address is 21st Main Road, 2nd stage, Banashankari. Name is Jalsa, restaurant name. And online orders, yes, we can order online. Book table, yes, we can book a table. And then we have rating. It has 4.1 rating out of 5. And this restaurant got 755 votes. And this is the phone number of the restaurant owner. This is mobile number. This is landline number. And the location is Banashankari. And then we have restaurant type. It's a casual dining. And then we have dishes liked by people. Here people like eating pasta, lunch buffet, masala papad, paneer, something. And we have cuisines. We have North Indian and Mughalai Chinese. And we have North Indian, we have Mughalai, we have Chinese. And then approximate cost for 2 people. Here 2 people can eat in 800 rupees. So reviews list. So here people have rated it as a beautiful place to visit, I think. Then we have menu item, and then we have listed in type. This restaurant is listed in buffet type. So this restaurant is listed in buffet type. And then the listed in city as Banashankari. So this is all the information which is in this data set for so in this way we have information about all the rows. So let's check the more information. So here we can see that all these are in object format, which is in string format. So here votes are in integer format, except this vote, everything is in string format. So here we can see that we have 51,000 entries. It means we have 51,000 reviews of various restaurants in Bangalore. Then let's check total number of null values. So here we can see that we have 775 null values in rating. It means we don't have 775 reviews. Ratings for these listings. And we have review list. We have all the review list. And we have 346 missing values in price, approximate cost for 2 people. And then we have dishes liked. We have 28,000 missing values in dishes liked. And we have 1200 missing phone numbers. Okay. Now let's see percentage of missing values. So here we can see that we have 15% missing values in rating, where users have rated from 0 to 5. out of 5, and here we have 50% missing values in dishes liked. Let's check more information about this data. So here only votes is in integer format, so we are getting mean, median and average only of this column. So here we have minimum number of votes are 0 and maximum number of votes are 16,000. It means 16,000 people have reviewed that restaurant, and 75th percentile people have reviewed 198 votes. Let's check the shape of our data. So we have 51,717 rows and 17 columns. So now let's check unique items in the menu. So what are the different foods in the menu? So we have chocolate fantasy pack of 5, pancake pack of 6, gulab jamun pack of 12, and we have gulkand short pack of 5. And in the same way we have so many items in this menu. So the list is very huge. So we have so many different type of menu items. We have prawn Singaporean noodles. So it contains list of vegetarian and non-vegetarian items that we can order online or we can dine in. So now let's create a plot to check whether the restaurant has a table booking facility or not, whether we can dine in by booking restaurant online or not. So we can see this. So here we can see that only for nearly 9,000 restaurants we have option to book a table, and for like about more than 40,000 restaurants don't have option to book table online. So here we are using count plot and we are giving book table column from a data frame. Now let's also check whether we can order online or not. So now we have checked whether we can book a table or not. Now let's check whether we can order food online or not. Let's run this cell. Okay, here we can see that more than 30,000 restaurants give us option to order food online. Not 30,000 restaurants, but more than 30,000 listings, which are data points. More than 30,000 data points have option to order food online. And here there are more than 20,000 restaurants listings where they don't have option to order food online. I mean, they are so backward. Like at this time everyone is ordering food online, even though if the restaurants are not online, then they will not be able to serve everyone. If you are online, then so many people can order from your restaurant. Now let's check various types of listed in type, which are like buffet and various other types of listing type. So here I'll select listed in type from data frame, and we'll write .unique. So it will give us all the unique listing types. So a few restaurants are listed in buffet type, cafes, delivery, desserts, dine out, drinks and nightlife, and pubs and bars. Let's create a plot to check all this listed in types. So here we can see that, let's zoom it. Let's scroll down and read various types of restaurants. So here listed in city we have areas from BTM layout, Electronic City, Fraser Town, HSR layout. And I used to stay here at Electronic City. And yeah, let's see various restaurant types. Let's scroll it down. So these restaurants are listed in blue color was in HSR layout, I think. Let's select only one particular restaurant, area. So BTM layout. Yeah, HSR layout, BTM layout, and Lavelle Road. So these three are in blue color. So let's check the restaurants which are in this area. So we have buffet type, we have blue in cafes, and then we have delivery restaurants. So we have more number of delivery restaurants in HSR layout and BTM layout. And also we have dessert restaurants, we have dine out restaurants, and then we have drinks and nightlife, and then we have pubs and bars. So I think pubs and bars are more in Koramangala. Now let's check the various restaurant types. We have how many unique number of restaurant types? Let's check them. So here we can see that there are so many different restaurant types. We have casual dining, cafe. So we have quick bites, we have cafe, and quick bites, quick bites. So many of them are repeating. So we have takeaway, we have casual dining, lounge, bar, bakery, dhaba. So sweet shop, food court, dessert parlor. So we have so many different types of restaurants. That is different. That is listed in type, and this is restaurant type. Now let's check top 25 restaurants of Bangalore. Let's create a plot for it. So here we can see that Cafe Coffee Day is the top restaurant in Bangalore. And then we have Just Bake, Empire Restaurant, and so many other restaurants. And then here we have Ambur Hot Dum Biryani. I think it's a Tamil dish. Now let's check all the unique ratings. So we will select rate column from data frame and apply dot unique method. So this will give us so many different type of unique ratings. So here it's 3.8 by 5, here it's 3.7 by 5, here it's 3.6 by 5, here it's 4.6 by 5, and here we can see that it's new, like okay, the restaurant is new, it doesn't have any rating. And here we have NAN. So we need to drop ratings like this. So this is not in numbers format, we need to drop it. So we can drop new and we can drop NAN. So let's do that. So here we are dropping new and NAN from our DF. So we are using drop NA method. Let's run the cell. So here we have all this rating in string format, because if one value is string, all the column, complete column will become string. So now we need to convert that string into float. So first we are separating them, and then we are converting into float, and we are storing it in data frame, and we are creating a column name rate. So we have existing column name as rate in data frame, so we are storing it in data. We have created a new data frame, we are just copying this into this. Let's run this cell. So now we have ratings as float. Now let's check whether there is any relation between the rating of the restaurant and the area in which the restaurant is located. So there will be few restaurants which are high rated because of their location. So let's check them. Let's run this cell and let's wait for it. So here we have rating as 4.0. So for this restaurants here the rating is 3.9. So here we have blue color as BTM layout. So here BTM layout has more restaurants which have good rating. So here the restaurants which are located in BTM layout has more rating on 3.7, 3.8, 3.9, 4.0, 4.1, 4.2, 4.3. But the more number of restaurants are with rating 3.9. And yeah, so these restaurants are high. So the restaurants which are rated with 3.9 are best selling restaurants. I mean, people order more from that kind of restaurants. Now let's create a distribution plot to check the restaurants. Let's run this cell. And here we have bins 25. So here we can see that more number of restaurants have rating as 3.9. So here it's 4.0, here it's 3.8 and 3.9. So more number of restaurants are with rating 3.9. Not only in BTM layout, but in overall Bangalore. So before we have checked the listed in type for each restaurants. Now let's create a bar plot to check listed in type of restaurants. So here we are creating a plot. Let's see this. So we have more number of delivery restaurants, and then we have dine out restaurants, and then drinks and nightlives are less, pubs are also very less, desserts are also less. So more number of restaurants are either dine out or delivery. Now let's use Folium library and create maps. So first we need to have location data. So here we have locations. So we will separate all the unique locations and we will create a locations data frame. Let's run the cell. Now let's collect latitude and longitude location for all these locations which are in our location data frame. So here we are using geolocator, which is from GeoPandas. So these will help us to get location codes, which is longitude code and latitude code. So we will collect the information about latitude and longitude code and we will save in this data frame. Let's run the cell. So now we got all the latitude and longitude locations for all these location names. Now let's check the location head. So here we have name as Banashankari and we don't have any location for this. And for Basan Vanagundi, we have latitude and longitude location, and for Jayanagar we have latitude and longitude location. Yeah, for a few locations we have latitude and longitude location, and for few locations we have NaN values. Now let's create a base map using folium.map. So and we are giving one default location as 12.97 and 77.57. And the default zoom is 12. So you can change this, but I'll use the same. Let's run the cell. Now let's get the restaurant count with their name and location. Let's run the cell. So let's see the locations. So here we have Jayanagar, we have count as 1030, which is 1030. So we have 1030 restaurants in Jayanagar with this latitude and longitude, and we have 1050 restaurants with this latitude and longitude. So here are the list of restaurants. In West Bangalore we have only 2 restaurants, and the more number of restaurants are in Jayanagar, Church Street, Electronic City. Now let's create a base map. We are also creating a heat map on it. So let's run this cell. Now let's run this cell to create a base map. So here we can zoom it and we can check various restaurants in the Bangalore city. So we can zoom it, we can change the map. So we can drag and zoom it and we can check various locations of restaurants in the Bangalore. So here it's showing like 3 km, which is 2 miles. So there is some particular measurement. So this is done with the help of leaflet. Let's proceed further. Now let's create a heat map for South Indian restaurants. So here we are creating a function where we can give the column name and cuisine type. So here we are giving cuisine as column and the cuisine type as South Indian. So here we are giving column name and the data point name, data point type. So let's run this cell. So here we can give input to that function. So and then we can create a heat map. So here we can see all the South Indian restaurants in Bangalore. But you will not find any information like Google map So in Google Map, when you click on any location, you'll get information. So you'll not get any information, but you'll know the locations of that restaurants. So you cannot use map check the route from your location, but yeah, you can check overall city map. So not only city, it's showing the whole country map. So you can use Folium to check any locations. Let's drag it. Now let's check restaurants of North Indian cuisine, like North Indian restaurants. So this is the heat map for North Indian restaurants at various locations of Bangalore. So that's very interesting to get locations. Yeah. Now let's proceed further. Let's start the model building part. First, let's check the information about our data frame, because we have many float type. Sorry, only one float type and others are string type. So we need to do one hot encoding. So we need to convert these things into integer or float type. Let's do that. First, let's convert the Boolean value. So here in online order, we have yes or no. So we can make it to true or false. Then it will be converted into 1 and 0. And also for book table column, there is an option of yes or no. But we can also convert that into true or false. So that will eventually, that Boolean values will be converted into 1, 0. Let's run this cell. Now let's encode our data set and create a new data frame, which is df_en. So first we will create a function and we will apply a function on our copy of our data frame. Let's run the cell. Now let's check the information about the newly created data frame. So here we have integer, 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 float, integer. So only this approximate cost for 2 people. So this column is as a string, other all columns are converted into float or integer. Let's check the data frame again. So we need to convert this approx cost for 2 people, because in so many places we have, if the price is more than 1000, there is a comma. I saw that data set before. So yeah, I'll show you how it looks. Yeah, here it is. So this is approx cost for 2 people. Here we have comma. So even one data point has comma, the whole complete column will be converted to string. So we need to remove this comma and club this together. So for that, we are using dot as type str and we are applying a lambda function and we are replacing comma and we are converting it to float. Let's run the cell. Now let's check the data frame again. So now we can see that all these columns are converted into either float or integer. So all of them are in numerical format. See here you can see that all of them are converted into numbers. So we had a restaurant, we had review, we had so many things. But now everything is converted into numbers. So the complete data set is in numbers format. Let's proceed further. Let's create a correlation map. Heat map. So we have not created it before, because so to create a correlation map we need everything in numbers. So as just now we have converted all the columns into number format, so we are checking the correlation matrix now. Let's create a heat map of correlation matrix. So here our main column which will predict is rating, which is rate. So this is our main column. Let's check which values are correlated with this column. So here we can see that these votes are correlated, I mean highly correlated, and then yeah, and this approx cost for 2 people is negatively correlated, and this location is also negatively correlated, and the bookatable option is also correlated with it, I mean negatively correlated. So yeah, and other columns like restaurant type also correlated, positively correlated. The main thing which is very highly correlated is votes, and after that we have restaurant type, and then we have dish liked by people, and we have cuisine type. So these are few columns which are mostly correlated. Now let's split the data set. Let's split it into training set and test set. First, we will divide our independent variables and dependent variables. So we are dropping rate column from our data frame and we are storing it in X, which are our features data frame. And then we are storing only rate column in Y. So in X we will be having all our features, in Y we will be having our label, which we are going to predict. And we are splitting it with the help of train test split, and we are storing it in X train X test, Y train Y test. And we are giving input as X and Y, so this is X and this is Y. And the test side is 0.2, which means 20% is test size and 80% is train size. So out of this 50,000 data points, 20% data points, which means 10,000 data points will be in test set and 40,000 data points will be in training set. Let's run this cell. Let's also check the head. So from head X train we don't have a rating column. Let's check the Y train. So here we have only rating column. Let's check the X test head. Here also, except rating column, we have all other columns, and even in Y test. And we have only rating column in Y test. Okay. Let's proceed further. Now let's train our model. Let's first start with linear regression. So we are importing R2 square linear regression. We are calling the linear regression, and then we are fitting it to X train and Y train. And then we are predicting it on X test. And we are checking the R2 square error on Y test and Y predict. Let's run this cell. Let's check the R squared error. So our R squared error is 0.24 for this linear regression. So the linear regression is not that good on this data frame. Let's check other regression types also. First, we are installing cat boost. Let's install it. So cat boost is a boosting type regressor. Let's check the accuracy for this type. Let's import the cat boost as we have installed it. Now we can import it, and we are using number of estimators as 200, and we are giving loss function as mean absolute error, and we are giving evaluation metrics at root mean squared error. And then finally we are fitting that model, cat boost regressor model, on X train and Y train, and then we are predicting it on X test. And finally we will check R squared error on Y test and Y predict. So here we got R squared error as 0.34. Let's check random forest. So from sklearn.ensemble import random forest regressor. So we are importing random forest regressor, and we are giving number of estimators as 600, and we are giving max depth as none, and we are giving minimum sample split as 2, and minimum sample leaves as 0.001, and these are all other parameters. So once we create this model, we will fit that model to X train and Y train, and then we are applying this, predicting it on X test, and finally we will check the R squared error between Y test and Y predict. So Y predict is the predicted Y, and Y test is original test. Let's run the cell. So here we got r squared error as 0.87. Now let's start building our decision tree model, and we'll check r squared error for that model. So first we are importing decision tree regressor. And then we are giving input parameters, splitter is best. And these are all the hyper parameters, and we need to tune it properly. And we are giving minimum sample leaf as 0.0011 and minimum sample split as 2. So you can use grid search CV or random search CV for hyper tuning the parameters, but I have not used in this case. And then we will fit that decision tree model on X train and Y train, and we will predict it on X test, and finally we will predict our r squared error, and then we will predict our r squared error on Y test and Y predict. Let's run this cell. So here we got r squared error as 0.79, and for random forest we got 0.87. So decision tree and random forest both are good, but random forest is better comparing to all other models. So here we got only 0.34, and for linear regression we got I think 0.24, right? Yeah, it's 0.24. It's very low. So comparing to all other models, so random forest is working good. So you can use random forest model to predict various ratings of any restaurants in Bangalore. So this is how you can build a different model on this kind of problem. So here in this case study, we worked on reviews given by users on various restaurants. So based on that previous reviews, we will predict other restaurants, new restaurants. Like what should be the rating if they have cuisine, this type, if their location is in BTM layout, if they have this type of dish, and their approximate price is this much. So based on all these input parameters, we will predict the rating. So based on that, even if it is a new restaurant, we will recommend it to our users. So we will predict the rating in advance before the users can give it. So in this way, you can build a model on this data set. You can build a few other models, few different type of models. You can use lasso regression, ridge regression, and you can use various other regressions also. And that's it for this case study. See you again in the next case study. Thank you.